Jai Hind everyone. I am Kajal Kaushal, Assistant Professor of IT Department, Akgec Garg Engineering College. Today, my video lecture is about the direct memory access. It's a very important topic in terms of the university exam as well as for all the entrance level exams also. And it's about how the CPU deals with all the processes, with all the instructions. So, basically, there are three approaches. The program initiated approach, where the CPU has to keep idle and waits till the devices ask the CPU or seeks the help of the CPU. So, again and again, CPU keeps on waiting for the task to get started. Second one is the interrupt initiated, where the CPU handles one program as well as the interrupt mechanism. But in both the cases, a waiting time is there, be it for the interrupt or for other device programs. So, the best performance is achieved by the direct memory access, where the CPU has to be bypassed by the input-output devices and the memory. The transfer can be by the input-output devices to the memory or vice versa. So, let's see and get started with this particular topic. In this approach, the interface transfers the data into and out of the memory unit through the memory bus. So, we all know that there are three types of the buses: address, control and the data bus. So, here the data is transferred via the memory bus, via the memory unit or through the input-output devices, and the CPU is being bypassed. Moreover, we can say the CPU is idle and has no control of the memory buses. So, here the DMA controller takes over the buses to manage the transfer directly in between the input-output devices and the memory. And how this all happens, this we need to know. Moreover, all the control buses, the address bus, the data bus and the control bus, these three buses are there with the CPU. That means the direct memory address needs a controller to take the charge of the buses to transfer the data directly, bypassing the CPU. For that, there must be some mechanism. So, the mechanism, the interface that is being provided to continue with this process is given by the DMA controller. This DMA controller is that particular, we can think of it as an analogy of a class where there are many students and a teacher has to give some notes, has to provide some material, study material to all the students. Now, it would be very tedious job for the teacher to handle each and every student, to pass on each and every student that particular study material. So, better it would be to give all the notes, all the study material to the monitor, and then monitor will handle all this transfer from the materials of teacher to the particular student. So, like that, the DMA controller acts as the monitor of the class. It takes whatever data is there with the input-output device and gives it to the memory, or takes the data from the memory to the input-output devices. So, it acts like the monitor of the whole system. This process is being governed by two particular signals that are the part of the control bus, that is bus request signal and bus grant signal. The CPU is placed idle whenever the bus request signal comes from the device to the DMA. The device, suppose this is the input-output device, it will send the bus request signal, or moreover we can say it will send a DMA request to the DMA controller, and this DMA controller will send the bus request to the CPU. When the CPU grants the permission to the DMA controller, then only the input-output device can use the DMA controller to provide the data. For this, we need two signals, that is bus request and bus grant. This is the way the CPU bus signals acts for the DMA transfer. So, we can see here that there are two signals, bus request and bus grant. Okay. Till the bus grant is equal to 0, that means the initial state where the bus grant is 0, all the bus control is there with the CPU when BG, that is bus grant, is equal to 0. Whenever there is a bus request from the DMA, then after sending some of the information to the DMA controller, like the information that I'll discuss in the coming slides, the information about the address, the information about the data, the information about the control signals. After giving all the information to the DMA controller, the CPU, what it does, it makes the bus grant symbol as BG is equal to 1. When the bus grant signal becomes 1, it converts all this process to the high impedance state. High impedance state as in the CPU becomes disabled for this particular task. The task that is being executed, that will be executed by the DMA controller, for that particular task, CPU becomes disabled. So, for the CPU to become disabled, the bus grant should become 1. Okay. So, the same thing is written here. The CPU activates the bus grant output to inform the external DMA that the bus request BR can now take the control of the buses to conduct the memory transfer, and that too without the processor. So, it's all about the bus grant becoming 1. Till before that, the scenario was that the CPU was handling that particular process. When the bus grant becomes 1, now the CPU will move aside and it will give the chance to take over the bus control to the DMA controller. Now, don't think that what the CPU will do. Whether the CPU won't do any of the tasks? No, it's not like that. By the time the transfer of the data is dealt between the input-output devices and the memory, whether the transfer is to and fro, whatever, at that time the CPU will perform some other task. Like, say for example, video is being transferred from the disk, from the hard disk to the RAM. Okay. At the same time, simultaneously, CPU must be handling some browser information. It must be handling some other applications for the user. So, both the tasks are handled parallelly, one by the CPU and another one by the DMA. And when the DMA terminates the transfer, whatever the data was to be sent to the device from the memory or from the memory to the device, in both the cases, when the DMA will terminate, then it will disable the bus request line. And as soon as the bus request line becomes disabled, the CPU disables the bus grant signal. That means the bus grant will again become 0 and it will return to the same impedance state. From the high impedance state, it will again convert and make the CPU enable and will allow the CPU to take over all the bus information charges. This is the DMA transfer in a computer system. What happens? The input-output peripheral device request for the DMA, like it could be any of the requests to transfer the video, information from the hard disk. It can be any SDD. It will transfer the video to the RAM. At that time, it will request the DMA controller to handle this transfer process. DMA chip is having these two registers. okay, and these two signals. Then this DMA select and the register select both are handled by the CPU. These are the bus request and bus grant signals, and this is the interrupt that will be sent by the DMA controller to the CPU. First of all, after getting the DMA request from the input-output peripheral device, the interrupt is sent to the CPU. CPU will get to know that some of the task, some of the device is asking it for some information or any of the data is being sent to the CPU. It will see that there is one bus request from the DMA controller. As soon as the CPU gets the bus request, it will manage the data select and register select. It will enable it and will send the address also to the DMA controller. This address is sent by the CPU to the DMA controller. Okay. This address will allow this DMA to be get selected and this register to be get selected. After that, the CPU will also send the control signals for read and write and also the address and from where the data is to be read, from where the data is to be written, like this information, to the read, write and address data signals of the DMA controller. After all this process, CPU will grant the permission to take over all the buses to the DMA controller. That means the BG will become 1 and this bus will be granted to the DMA controller. Once the DMA gets the bus grant permission, that means it has taken the permission to handle all the buses, at that time the DMA will select its read, whether the process is read or write, or from where the address is to be started, how much data is to be read or how much data is to be written to the memory. Whatever these informations are there, these information are then conveyed to and fro via this data bus, address bus and the control bus. These two are for the control bus, read control and write control. This is the data bus and this is the address bus. So, I have already discussed that this information is given to the DMA controller by the CPU itself. CPU has once given this information to the DMA controller and after that it has given the grant permission to the bus. It's not like the DMA is already deciding that whatever it's to be read or write. It's given, this information has been conveyed to the DMA controller by the CPU only. Okay, this transfer from this DMA controller to the input-output device and memory, it can be done via two ways. One is the DMA burst and another one is the cycle stealing. Okay, the transfer can be made in these two ways. In the burst process, a block of data, suppose the starting data is from the address, this a hexadecimal value 2000H. From here, all the data in a bulk will be moved to and fro. That means from the IO device to the memory or from the memory to the IO device, starting from this address. In the previous slide, we saw that the address is being mentioned in the address select position or the address select register, and here this information is already there from where the data has to be started. Okay, so suppose the data has to be started from 2000H of the value the starting block, and from here a bulk of data has to be moved, like the video has to be transferred to the RAM at a time. That process will be DMA burst, and this information will be already there in the mode of transfer. There are three things: the starting address, the word count, and another one is the transfer mode. So, this information will be already there. In cycle stealing approach, we see that the data is sent in some chunks. So first a little bit amount will be sent. Then the CPU will again take the control of the buses. It will perform some of the task. Again, it will give the transfer. It will transfer all the bus control to the DMA controller once this task is being done. So in chunks, the DMA controller steals the cycle time of the CPU. So as the DMA controller steals the cycle time of the CPU, it's called as the cycle stealing. And in the DMA burst, it doesn't steal, it transfers all the data at a time. So see, you can see that the cycle stealing allows the DMA controller to transfer one data word at a time, and after which it must return the control of the buses to the CPU. So this is what I mentioned just now, that there are three registers. One is the address register, second is the word count register, and third one is the control register. Address register specifies the address from where the data needs to be fetched. The starting point, it's the starting point. The word count register is the amount of words. Suppose we need to transfer 100 words at a time, or maybe by using the cycle stealing approach. So it will start decrementing as soon as the transfer starts, from 100 to 99, 98 and likewise. So it starts decrementing, and the amount of words can be transferred by both the modes, data burst or by the cycle stealing approach. The control registers tells the DMA controller what type of mode is to be used, whether it is read, whether it is write or whatsoever. Okay, so this is what I just discussed. It's incremented or decremented by 1. Each word transfer and internally tested for 0. The control register specifies the mode of the transfer, and address register contains the address to specify the desired location in the memory. Okay. In the initial slide, we saw that there is one DMA select and one register select input. These two registers that are used by the DMA, are selected by the CPU only. That means the CPU enables the address bus. CPU transfers the address bus control to the DMA by selecting these two, by enabling these two registers, that is the DMA select and register select. It has to enable itself, and then only the DMA can take the full control of the all the particular data transfer. And when the bus grants input is 0, the CPU can communicate with the CPU registers. At that time only, it can handle all the register transfer mode. It can handle the information like what is the starting point, how much data is to be transferred, and what mode is to be selected. It will also activate whether it is read or write control. So this is how the DMA works, and it sends the value of all the information to the address bus buffers. Okay, this is the block diagram for the DMA controller. From here, the IO devices send the DMA request to the DMA controller, and then when all the information that we discussed just now, that whether this DMA will be selected by the CPU, this register will be selected by the CPU, this bidirectional read and write control signals will be activated by the CPU to be read or to be written. Bus request signal is sent by the DMA controller to the CPU, and bus grant is received by the DMA controller. The interrupt is sent to the CPU, and this is the data bus buffers. Here it decides whether it has to move in chunks or at a time, that is data burst is there or cycle stealing approach is there. The address register keeps the starting value. The word count register keeps track of how many words are to be sent, and the control register handles whether it is read or write. So overall, we can say that the CPU communicates with the DMA through the address and data bus with any interface unit. And this is the important part to be mentioned, that when the whole information is being conveyed, when the bus grant is 0 and when the bus grant is 1, then the DMA control takes the control of all the charges and sends the data to the input-output devices or to the memory. So moreover, we can say that DMA is helpful for all the communication, and it can help to access it very fast. So thank you so much everyone. If there is any confusion, you can do right. Thank you.